Assalamualaikum warahmatullahi wabarakatuh. I am Siti Raihana binti Muhammad Saleh with ID MA18119. I am from Group 3. So, as for today, we're going to present our experiment, which is the fluid friction in pipe. So, as for the introduction, the experiment was undertaken to measure the head loss in pipe due to the friction in between the fluid and also the wall of the pipe. Different flow rate was introduced along with different types of pipes. Therefore, friction factor was measured. Fluid velocity was also studied and related to flow rate and also the type of pipe during the experiment. The procedure then was repeated for different pipe, which include straight elbow pipe 90 degree, bend pipe 90 degree, and 45-degree pipe. Reynolds number was used to understand the variation of flow between laminar and turbulent flow. The head loss found to increase of velocity. So I'll continue the presentation with the problem statement. Friction pressure loss dissipates the energy needed to drive water into a pipeline. Friction inside a pipe causes major loss, whereas minor losses occur where a part, valve, bend, or other disturbance occurs. The flow rates, pipe length, pipe diameter, and also the friction factor basically dependent on the roughness of the pipe as well as whether the flow type is turbulence or laminar. While the head loss reflects an energy loss, it does not represent a loss of the fluid overall energy. Frictional head loss causes a corresponding increase in the fluid's internal energy. Different types of pipe may have different friction loss. So, to address the issue of the mechanics of fluids, friction phenomenon in pipe, and also the losses in pipe, the friction losses in pipe experiment is conducted. Okay, I think that's all from me. I'll pass the presentation to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Rahana, for the present. So I will continue for the objective and scope. I will introduce myself. I'm Muhammad Amir Afiq bin Saidi, MA18158. For our objective is to design and evaluate complete measurement techniques and experiment procedure, and also to investigate the head loss with different velocity. So our scope is we using the PVC pipes to determine the head loss with the different velocity in PVC pipes. And we also using all factors that contribute to head loss using the 90-degree bend PVC pipe, the straight line PVC pipe, that we also using a few types of PVC pipe. That's all for me. Thank you.
Hi everyone, my name is Lim Zhen Wei and my metric number is MA18151. And now I will present for the part of theory. Fluid friction occurs between fluid layers that are moving relatively to each other. This internal resistance to flow is named viscosity or viscous drag or fluid friction. In normal terms, the viscosity of a fluid is described as its thickness of the fluid. Thus, water is thin, having a low viscosity, while honey is thick, having a higher viscosity. The less viscous the fluid, the greater its ease of deformation or movement. All real fluids offer some resistance to shear and therefore are viscous. Liquids and gas are called fluid because they can made to flow or move. In any fluids, the molecules themselves are in constant, random motion, colliding with each other and with the walls of any container. The movement of molecule is governed by two types of force which are present between the molecule of the substance itself and between the substance and the other material in contact. The first one is cohesive force. Cohesive forces are attractive force that exist between molecules of the same substance. So, cohesive force are the main cause of viscosity. The second one is adhesive forces. These are attractive forces between unlike molecules. An object travels in a fluid found that it loses its energy in order to overcome the fluid friction. The shape of an object plays an important role in increasing or decreasing the fluid friction when it travels along with it. For the laws of fluid friction, there are three laws in the fluid frictions. The first law mentions that the fluid friction increases with an increase in the area of contact between the surface and the fluid, while the second law mentions that the fluid's friction increases with an increase in the velocity gradient of the substance. Third law says that the fluid having a higher coefficient of fluid friction has a higher value of fluid friction force. The rules hold differently for different lubricants. It is indirectly proportional to the temperature of the lubricant. There are a lot of factors that affecting the fluid frictions. For the first one is nature of fluid, the viscosity of fluid, the shape of the body, the temperature, the surface area of the body, the speed of the body, and finally the pressure of the body. All these 7 factors will affecting the fluid friction. That's all from my presentation. Thank you very much.
Assalamualaikum. My name is Syed Kemal Irfan bin Tuan Kasmadi. My metric number is MA18123. I have to present the method and procedures. So the method determined by measuring the pressure head difference between two fixed points in a straight pipe with a circular cross section for steady flows. And the second one, the volumetric flow. Control the volume by using the control valve and take the number in the pressure sensor to calculate the head loss, velocity, Reynolds number, coefficient of friction by using the formula given. So next, the procedures have a few steps, and the step 1 is set the apparatus based on the figure 1. So this is the figure 1. Set the pipe, the bend pipe, the pump, and so on. So the second one is open the valve or turn it to the left. So as you can see in the picture here, we need to turn the left to open the valve to let the water flow through the system. So step number 3, turn the pump on to make sure the water flow along the pipes. Okay, so the step number 4, use the control valve to adjust the volume of water along the pipes. So the step 5, close the unused valve and run the flow until all air is purged. So we need to close unused valve. And step number 6, put the pressure sensor along the pipes to measure the pressure. So we need to put the pressure sensor along the pipes to take the reading that has pressure sensor produced. So step number 7, repeat the step number 1 until 6 3 times to obtain the accurate result. So we must take the 3 times for avoiding the error. So lastly, step number 8, repeat step number 1 until 7 for elbow pipe 90 degree, bend pipe 90 degree, and bend pipe 45 degree.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMED bin Nasrun, MA18133. I am from Group 3. So today I will present the Chapter 4 result and discussion for the friction losses in pipes. So the formula that has been used is the velocity formula, which is the mass flow rate divided by area, which is the mass flow rate is given in the data. Next, the formula of Reynolds number, where rho is the density of the water, d is the diameter of the pipe, and mu is the kinematic viscosity for the water. So I have been using the properties of water at 20 degrees. So I am referring to the books. Next, for the friction coefficient, I have used 64 of Re, which is the formula for laminar flow. The head loss formula is the KL, which is the friction coefficient for the pipe fittings. V is the velocity of the flow, and G is the gravity value. So after I've been done the detailed calculation, which is doctor can find in my reports, the tables is like that, where the straight pipe have the KL of 0.01 with the measured head loss and volumetric flow. It has been given earlier. The measured friction coefficient that we can find here is based from the Moody chart that I've been referred before, as after I calculated the toughness ratio of the PVC and the Reynolds number. So the velocity that has been detailed in the report. So this is the table for elbow pipe 90 degree. KL is equal to 0.75, which is measured head loss. Maximum is 0.1154. The bend pipe 90 degrees KL is equal to 0.3, which is the measured head loss. Maximum based on the maximum flow rate is 0.1254, and the bend pipe 45 degrees KL is to 0.4, and the volumetric flow maximum is same to the others, but the measured head loss is different. So for the graph, I have been use the software to generate the graph, which the doctor can find detailed graph in our report later. We have a 4 type of graph, which is the measured head loss versus the volumetric flow. This is the other two. So for discussion, we can get the number by calculating the velocity of the flow first. The graph indicated the head loss of the fluid based on different fitting, and bend pipes 90 degree has the highest head loss. The velocity is directly proportional with head loss for measured and calculated data. So for the value of the calculated and measured data is different, which is we can see in the table, which is pretty large, but we can see the pattern of the data is same between the measured and calculated data, which is the head loss will be increasing based on the increasing of the velocity.
For the conclusion, basically this report describes the process of the experiment about the pipe friction and explore the calculation. So the flow of fluid in pipe is accompanied by the loss of energies as a result of the interaction between the fluid and the viscous stresses on the wall of the pipe. The energy loss might be formed from pressure loss in the system due to the friction of bend pipe. As you can see in the discussion earlier, we can conclude the velocity of the fluid will be increased and the head loss will also be increased. This is because of head loss is directly proportional with the velocity of the fluid. So the result might be not accurate due to the error when taking the measurement or data. Okay, so that's all from me. Thank you.